All right, now we're going to talk about the addition method, which is another algebraic method for solving systems of equations. And I want to point out that for any of these systems, you could use the addition method or you could use the substitution method. And as long as you're doing everything correctly, you'll get the same exact correct answer. So if we look at number 4, 3x plus 2y equals -5 and 2x plus y equals -4, notice that we already solved this using substitution back in number 2. We had the same exact system of equations, and we got -3,2 as our answer. So if my prediction is in fact true, then we should again get the solution -3,2 for number 4, even when we use the addition method. So let's see if I'm correct. I should be. All right, so following the steps, first it says write both equations in standard form. And for number 4, these are already in standard form, but just a reminder of what this means. This is that form ax plus by equals c. So for example, if the second equation in number 4 had been written in slope-intercept form like that, then we would want to rewrite it by moving the x term over to write it as 2x plus y equals -4. So that would be our first move, but we don't have to do that because they're both in standard form. So the important thing is you should have your x term, your y term, your equal sign, and then your constant, your number. Make sure that those are all lined up vertically in order for this to work. And ours are. Numbers 4, 5, and 6 all have equations in standard form, so we won't have to deal with this. But just so you know, that's what that means. All right, so second step, and this is really the key step in this addition method. Multiply one or both equations, so one or both equations, by a non-zero number, so by some constant, to create opposite coefficients for one of the variables. And that's the key, creating opposite coefficients. So looking at number 4, for example, I see that we have this plus 2y in the top equation, and then we just have a plus y in the bottom equation. So focusing on those y's, by opposite coefficients, that means for y, we would want to have a plus 2y in one of our equations, which we already have, and then we'd want the opposite, a minus 2y in our other equation. So that's what we mean by opposite coefficients, same constant, opposite signs in front of the same variable. All right, so we want to keep that first equation as is. So 3x plus 2y equals -5 because it already has our plus 2y in it. But then I want to take my second equation and I want to get this plus y term to be -2y. So if I multiplied it by -2, that would give me my -2y term. So if I multiply the entire left side of the equation by -2, and then if I match it by multiplying the right side, the constant, also by -2, this gives me -4x minus 2y equals -4 times -2, which is +8. All right, now comes the addition part, or sometimes it's called the elimination method, because we're going to add up our two equations, and by doing that, we'll see the elimination of one of our variables. So 3x minus 4y gives, 3x minus 4x gives me -x. Positive 2y minus 2y, the y variable is eliminated, those cancel to 0. And then -5 plus 8 gives me 3. So this says -x equals 3. Divide both sides by -1, and we get x equals -3. So that's our x coordinate, and so far so good. Remember, I was expecting to get -3 too. We've got -3 for x so far, so that's a good sign. All right, and then for our y variable, so we added the equations vertically, we solved the remaining equation to get x equals -3, and now we're going to substitute in the value we just found for x in this case into one of the previous equations to find the second variable. So we already have x, we want to get y. We could put x equals -3 into this top equation or into this bottom equation. Either one is going to give us the correct y value. So maybe I'll just choose the second equation. Does not matter which one I pick. So I'm going to pick the second equation, 2x plus y equals -4. I'll replace x with -3. And then adding 6 to both sides gives me y equals 2. So there's my ordered pair -3, 2. So remember we solved before using the substitution method. Now we solved the same system using the addition method, got the same exact correct answer. And remember again, this represents the point at which those two lines intersect when we graph them. All right, so solving number 5 using the addition method. Now we have 2x minus 5y equals 6, and then 3x minus 4y equals 9. So we could either eliminate the y variables like we did before, and in this case we would want, let's see, we've got -5 and -4 for coefficients. 5 and 4 both go into 20, so maybe we would want a plus 20y and a minus 20y. So we could go after our y's. And if we did that, we would maybe multiply the top by, let's say, +4 on both sides to get -20y. And then we'd have to multiply the bottom by -5 to get that +20y. So we could do that. But because we eliminated our y's in the previous example, let's go after poor little x this time. So I'm going to eliminate our x's. So if you eliminated the y's with what I just suggested, you would be totally fine. You'd get the correct answer. Instead, I'm going to go after our x's. So now we have 2x and 3x. 2 and 3 both go into 6. So let's say we want a plus 6x and a minus 6x. That's our new goal, to eliminate x's. All right, so in the top equation, I have a 2x. So what if I multiply that by 3? So I just need to make sure that I multiply by 3 on either side of my equation. This is going to give me my plus 6x. So 3 times 2x is 6x. Minus 15y equals 18. For my second equation, now I want that -6x. I already have 3x, so I need to multiply by -2 on both sides of the equation to get that -6x. So -6x plus 8y equals -18. All right, so I've got my opposite coefficients for x. And now I'm going to add these vertically because they're all in standard form already. 6x minus 6x adds to 0. -5y plus 8y adds to negative. Write a negative there. -7y, so 0 minus 7y. And then 18 minus 18 adds to 0. So now I have 0 minus 7y, which is just -7y, equals 0. And people kind of freak out sometimes when they see something like this and they're like, 0, but 0 is a number. You guys have probably dealt with 0 plenty of times in your life. We can take -7y and divide it by the coefficient -7, as long as we also divide the 0 by -7. And if you're kind of having a brain fart and can't remember if you're allowed to do this, ask your calculator. What's 0 divided by -7? It's 0. So we solved and got y equals 0, so that's the y coordinate in our ordered pair. Okay, so now to find x, we pick either the top equation or the bottom equation, doesn't matter which one, plug in y and see what we're left with. So I'll take the top equation, 2x minus 5 times 0 equals 6. So 2x equals 6. Divide and we get x equals 3. So we have the ordered pair 3, 0. If we were to graph these two equations, graph them on the xy axis, they would intersect at the point 3, 0. All right, so number 6, solve using the addition method. So maybe let's go after our x's again. I've got 4x and 6x. 4 and 6 both go into 12, so maybe I want a plus 12x and a minus 12x. So how about I multiply the top equation by positive 3. So 12x minus 18y equals 36. And then for my second equation, now I want my negative 12x, so I'll multiply by -2, going all the way across. So negative 12x plus 18y equals negative 24. All right, so now I'm going to add these vertically. 12x minus 12x adds to 0. Negative 18y plus 18y also adds to 0. And then 36 minus 24 adds to 12. So at this point, I have 0 plus 0, which is 0, equals 12. And notice that there are no variables, right? I can't solve for x, I can't solve for y, because they both have left the building. They went bye-bye. So as a reminder, we saw this in example number 3 in the previous video. Remember, our rule is if we have a true statement, then we have infinitely many solutions. If we have a false statement, then we have no solution. So in this case, we have a false statement, right? 0 equals 12. That's false, right? 0 equals 12 is a false solution. So the false statement indicates that the system has no solution. No solution. So graphically, what does this mean? Graphically, what does this mean? So let me just erase this part so we can take a look at our original equations. So if I were to solve both of these for y, for example, so if I solve my first equation for y, first I'd subtract negative 4x from both sides, and I have negative 6y equals negative 4x plus 12, divide by negative 6 all the way across. So I get y equals, what is that, positive 2/3 x minus 2. And then if I do the same thing for my second equation, solving for y, divide by negative 9, negative 9, negative 9. I'm going to get y equals positive 2/3 x. Positive 12 over negative 9 gives me negative 4/3. All right, so let's go ahead and graph these two to see what they look like. But already I can see that they have the same slope, right? So for my first line, 2/3, oops, 2/3, there we go, looks better, 2/3 x minus 2. For my second line, 2/3 x, and then minus 4/3. I've got parallel lines, right? I've got two lines that have the same slope, positive 2/3, but two different y-intercepts. So where do they intersect? They never intersect. So because they never intersect, and our solutions are intersection points, that means our system has no solution. There's no intersection point.